Good day, everyone. I'm Joy Avelino.
Hi, I'm Karla Agregado.
We're going to present for this year's decode a web of threats. So, the web from a web of threats comes from the web, World Wide Web, and we're going to show you via machine learning how is the threat landscape is seen. And as you might know, the role of big data, 2.5 quintillion bytes of data is generated per day, and threat data is no exception to the presence of big data. And cyber criminals, threat actors, adds to the abundance as they continuously up their game by tweaking old threats and creating new ones to evade detection. So to address this vast amount of threat data, security providers turn to machine learning as one of its solutions to automate processes as well as improve security solutions. So there are two parts for this presentation. So first one, Karla will give out insights regarding the web threat landscape, as well as she will also show you features we feed to the ML model. And then for the second part, I'll introduce to you the concept of natural language processing and how it can be used to interpret the threat landscape. I turn you over now to Karla.
Okay, thank you, Joya. Before I proceed, let me share you one of the quote from the greatest mathematician, which is Alan Turing, wherein he says that what we want is a machine that can learn from experience. So, especially in this time wherein we are having difficulty encountering this kind of pandemic. So, as humans, we also learn from experience. And in the cybersecurity, we also want a machine that can also learn from this kind of experience wherein we can protect people or customers from getting or being a victim in the cyber threats. So to start, let me also share you this recent article from HealthNet Security, wherein they tried to survey their employees, and it turns out that 40% of their employees who fall for phishing URLs cited that the main reason is actually distraction. So I think the idea is that because most people, especially nowadays, do multitasking, especially online. So the idea is that whenever they see emails or let's say URLs or web pages, they tend to initially trust, and especially if you see that they look like they are legitimate ones. But it turns out that most of this instance, there are still many victims of these kinds of attacks, especially phishing attacks. And on the next slide, as you can see, here's the Trend Micro's monthly phishing statistics. Here, you can see that there's a lot of phishing URLs every month, and there's a millions of them. And as you can also see, there's also a big rise of phishing URLs by the month of August. So let me share you some what are the possible reasons why there are a lot of phishing URLs this year. So first, on the next slide, you can see the top company targeted by phishing attacks. So since everyone is online and most likely there are a lot of people that are busy doing their or browsing their social media. So here in these statistics, you can see that Facebook is the most targeted by phishing attacks. So I think this is because most people lean to social media nowadays. And then after Facebook, it is followed also by PayPal, Runescape, and Apple, and so on. So if there's a global statistics, so we can also share local banks that can be a possible target of phishing attack. So for this one, as you can see, this is a sample of a phishing email wherein it targeted BPI company or BPI bank. So if there's any one of you who's working on BPI, so this might be something you should know. So in this slide, you can see that the phishing email actually looks like a legitimate one, but if you can see more on the details, there are some words that are actually misspelled. And then also the copyright cited on the email is also not updated. So normally, if the email is legitimate, the copyright should also be updated as well. And then for this email, it also contains a link, which is a phishing URL link, wherein it will redirect you to the actual phishing site or phishing URL of the BPI. So here normally, whenever the bank tries to advise their customers, the email shouldn't contain URL links. Most likely, the banks will advise you to go to their official website and do a login, and then that's where you can do your transactions. So, having said that, I'll go to the next slide wherein this one, it is about the number of phishing URLs and phishing emails that is based on Trend Micro's case submission. So these are the actual customer submissions wherein they try to file as case, and we as threat in the threat security, so we try to analyze them. So in these statistics, most of these submissions are actually mostly phishing URLs. There's only few on phishing emails, but I think most of the customer case submissions are actually more on phishing URLs. And as you can see, there's also a sudden increase on the month of June. So, what are the cause and effect, or what are the actually events that the phishing URLs took advantage in this year? So, as you can see, or as we all know, we are still encountering this pandemic. So, and this actually unfortunate event caused really a price on most of the people, especially those people who actually got infected or lost their job. And besides that, there's also a lot of events wherein the phishing URLs took advantage of. So first, there's this COVID-19 massive phishing and scam URLs. So during this pandemic, there's also a lot of fake statistics or fake login page on CDC, or even fake applications that is related to COVID-19. They took advantage of this one because actually the idea is everyone wants to be informed, wants to know what's happening. So I think this is one of the idea of the phishing authors, that they might actually have several victims when they use this kind of events or strategy in terms of phishing URLs. And then there's also the huge demand of work from home setup, wherein it leads to more phishing websites. Especially now, everyone is online, so there's also a lot of phishing sites that may involve like the Zoom application or Microsoft Teams. And then there's also this the start of online classes, wherein since everyone is trying to be safe at home, so there's also the start of online classes, and there's also actually a massive campaign that hits the UK, wherein it targeted the education industry. So, despite of all these events, these are the possible way wherein the cyber criminals took advantage of, so they can actually have more victims. And on the next slide, these are just the statistics wherein I tried to check the amount of sharing services versus the spam campaign or the current events that is used for phishing and scam URLs. So as you can see, there's only quite a few malicious URLs on spam campaigns. So these are based on the, again, customer submissions from Trend Micro. And then there's also a lot of malicious URLs related to COVID. And as you can also see, most of these URLs actually are using or abusing some domains that are related to sharing services. So this huge amount of URLs are can be from typo squatting, but as we observe these days, most of them are actually using sharing services. So, what are the top 10 sharing services that we seen this past few days? So, here, as you can see in the statistics, one of the top sharing services is actually OneDrive.live.com. And then we also have the Google APIs. And also the shortened URL that is bit.ly. So these kind of services are actually free, but since they are free, these are the type of platform that the malware authors or phishing authors try to take advantage of. So from this, let me share you what are the behaviors that we usually encounter from phishing URLs that uses sharing services. So as I said earlier, so most of the commonly used sharing services is the OneDrive or SharePoint, SendGrid, and AppBox. So from here, they poses to be like sharing document stuff, and then actually it contains a malicious link wherein it will redirect you to phishing sites. But then as the day passes by and this kind of attack also evolves, wherein the common behavior now is a chain of phishing redirection. So as you can see from the original URL with redirection, it will redirect again to another phishing URL wherein it is also another sharing services before it goes to the landing page. So this kind of chain of redirection is actually very kind of difficult to detect because they tried to um, go to one page to another, which is very difficult to detect. So from this one, we can help you give some idea on how machine learning can aid this kind of behavior. So first, what should be the data that we should look at? So first, we can actually check for like physical URL construction. And then we can also check for the actual content of the phishing URL. So first, what is the anatomy of the URL? So as you can see, or as might what we all know is that URL composes of protocol, domain, path, and so on. So from this different parts of a URL, we can actually check for some red flags or possible keywords that we can use to detect those phishing URLs. So from that, we'll be having some kind of fish eye. Wherein first, we can check for the length of the URL. Is it safe to say that if the URL that is have or contains a very long characters are malicious compared to the URLs that are much shorter, or maybe it is more possible that if the shorter the URL, the more it is malicious. So we'll have the machine to have that kind of prediction. And then we can also check for features that wherein the URL contains special characters. So since it is not normal for URLs to have special characters, especially on the domain part, because if I'm not mistaken, this kind of strategy is being used in the typo squatting. So normally, whenever a legitimate domain is being used, it shouldn't contain any special characters. And then another one, you can also search for keywords. So especially uh, in the path part of the URL or in the subdomain. So normally, phishing URLs contains some keywords wherein they used the common or generic keywords or company name, so they can deceive users from actually accessing fake URLs. And then there's also this URL that has contains another URL. So it's like a URL within a URL, wherein it contains or it redirects to different URLs or phishing URLs. Actually, there are some dependencies also on the browser. Depends on what browser you are using. So it will redirect you either to a phishing or a scam URL. So, but most likely, if it's a URL within a URL, most of the time it redirects to phishing URLs. And then that's for the physical or URL construction. So how about the web content? So actually we can use or we can do some web scraping. So there are different platforms for this one. You can use the most common one, which is the Beautiful Soup. Wherein in the Beautiful Soup we can check for HTML tags, because most of the time there are some malicious URLs that actually residing or hiding on these HTML tags. So for example, if we look inside a phishing URL, there are some web content wherein they contain malicious URL that is hiding on, let's say, on a form tag or an href tag. So the idea is that whenever the user tries to input or log on using his or her credential, those credential will be posted on those malicious URL. And then there's also some content wherein the source code is actually hiding on an encoded format. It can be on a base64 or let's say an escape format. So these are types of technique that might be very hard to also to detect, because you have to decode this kind of format before you can actually see the readable format of the source code. So more on the machine learning remedy for this kind of attack will I will turn you over to Joya.
Thank you, Carla, for explaining the features we can extract from construction as well as the content and feed it to the ML model. So well, while the use of features taken from human expertise is essential, there is still a blind spot or things us humans, we miss out when creating features. So this is another area where machine learning can help us and benefit. And this is where natural language processing comes into place. So you might wonder, where does natural language processing? Is it AI, ML, or deep learning? Well, just a review of terms. So for artificial intelligence, the aim of AI is to mimic the intelligence or behavioral pattern of humans or any other living entity. And machine learning is a technique used by which a computer can learn from data without using a complex set of different rules. So this is mainly based from training a model from data sets. And for the features discussed a while ago, this is where machine learning comes into place. And another subset of that would be deep learning, or deep learning is a technique to perform machine learning inspired by our brains, how our brains work uh, over a network of neurons. So it mimics our brain. So natural language processing is included. The field of NLP encompasses AI, ML, and DL. And the interesting thing is that yeah, it encompasses the tree. So NLP is used if the data being dealt with is text data and we want to get insights from it. May it be sentiment analysis, topic modeling, information extraction, and so on. So text data tend to be sparse, having hundreds and thousands of dimensions, words and phrases. And in order to apply ML technique to NLP problems, we need to convert unstructured text to structured format for the model to understand it. So yeah, natural language processing is considered a difficult problem in computer science, since it's the nature of human language that makes NLP difficult. Like how we inter like how we understand a word. We can we can say, "Oh, Karla, you look great today." I mean, Karla understands it. But if you say it to a model, won't understand it. You need to pre-process it, turning that unstructured sentence to structured data that the NLP model can understand. Well, we have tons of library we can use for this. So first is the bread and butter for machine learning. So the basics, Python, Pandas, scikit-learn. Then for NLP, you can use the following, Spacy, NLTK, and GenSim. And for next one would be PyTorch, TensorFlow, as well as Keras. This is for more on deep learning applications. So for this one, since deep learning mimics the brain, it's the one in charge for extracting the features it wants and trains by itself. For the demonstration of ML technique, we're going to uh, explore topic modeling using latent dirichlet allocation or LDA. So LDA is an unsupervised approach used for finding a set of words called topics in a text document. So a document can be part of multiple topics, and it's somewhat similar to clustering. And what's the use of this topic modeling? It helps in discovering hidden themes in the collection, classifying the documents, and the case in point for this experiment would be COVID 19 malicious URLs that were sourced globally and was tagged as scam or phish. And we can study the common characteristics among the URLs that were formed. For LDA, the input would be in document term matrix, and the output would be top words for each topic. And with the help of GenSim, uh, to go through the process of finding the best word distribution for each topic. So LDA, in a nutshell, makes use of a probability distribution algorithm to sort out the topics in a document. So first part would be the data pre-processing. So we loaded the 150,000 URLs to an array, and as you can see, it's still put together. So we may need to process it further to remove the, for example, the dash or the periods between. So we have this function to put spaces in between certain words, such as COVID 19, coronavirus, vaccine, etc. Next part would be we're going to be using a in-house library from Python, which is still the extract, to extract the domain, suffix, keyword, as well as the subdomain of the URL. So for this one, exploratory data analysis or finding insights from data, we're interested in the suffix. So as you can see, there are many, blog, com, in, cat, com. So what does it look like for 150,000 samples? So for this one, sourced globally, most of the URLs has a TLD, top level domain, of .ru or .russia. And second one would be .com. Third, dot .cz, and so on. And we can infer from this also as subject matter expertise, because the URLs from .ru may be generated, automated generated. And then, next part of the data pre-processing is separating it into spaces. So for this one, we're going to check out the domains. So as you can see a similar pattern between them. So there's COVID-19, and then there's word. Maybe it's also automated, came from a dictionary, and then place it there to create the URL. And here is the NLP LDA proper. So for this one, pre-processing, we extract the tokens or splitting the strings, and then we make a corpora or corpus that contains a collection. It's just a collection of texts. So for this one, the dictionary has 13,523 tokens, unique tokens. And there's this function called token to ID. So for token to ID, it just outputs what is the uh, ID of that term. So for the actual algorithm, well, this is the yeah, it only takes a line. So based from my experience also in machine learning, it takes a lot of data pre-processing to get it right, and the right knowledge to apply it in a for a model. So for this one, for this example, for this demonstration, the LDA model, we paste the corpus, the number of topics we want to be generated, and then the dictionary as well as the passes or how many times it is trained upon. And then here are the top 20 topics or the 20 topics that were generated. And I'll move over to the visualization using PyLDA-Vis. So you can see here the visualization of the uh, 150,000 URLs. This was generated using LDAs. So the one I showed you in the slides is the top 20 topics, right, with the terms for each topic. So it was transferred here to a library, help visualize it. It's PyLDA-Vis. So you can also hover over the topics. And for the colors, the blue corresponds to the altered frequency. So 6, there are, you can see, countries like India, France, Blogspot. So most URLs in this cluster have countries, and scam and fish URLs, and Blogspot was used. There's also another cluster here. When I was checking the clusters a while ago, it was cluster 9, Amazon AWS, most likely sharing services. Then we also have Live for OneDrive, as well as Azure Edge. So the topics here in the lower right most likely have sharing services as part of their terms. And you can see the other terms paired up with it. So as you can see, after the visualization, we gained some insights from it. And I turn you over now to Karla to discuss the possibilities for URLs in the web threat landscape.
Thank you, Joya. So, first, let me share you the actually public portal of Trend Micro, which is the global.sitesafety.trendmicro.com. So, this is available to all web users, wherein you can check if the URLs is that you're accessing is actually legitimate or not. So, anyone can access this page actually. And then on the next slide, these are the possibilities that what Joya says about the what will be the next step for fishing in the future. So first, if we were about to predict what will be the future of phishing URLs based on what we experience today, it will be first about the news sharing services. So I think there will be more news sharing services and cloud applications wherein it will be used for phishing attack, especially nowadays that everyone is doing all their stuff online and everyone like online learning or even their work. So I think these services can be abused in the future. And then another one is since everyone is also doing most likely online banking or mobile banking. So I think phishing and scam URLs may also leverage on this kind of new technology wherein they can actually create fake mobile banking authentication that can actually lead to targeting even telecommunication companies. And for the final takeaway on this presentation or for the machine learning, let me turn you over to Joya.
So thank you, Karla. Now, for this presentation, we walk you over to the hardships of data pre-processing, feature extraction, and subject matter expertise is really important. Uh, I would like to leave you with this diagram. It's from Drew Conway. So as you can see here, there are three circles: programming, math and statistics, and subject matter expertise. Mhm. So for this one, I would like to give a note that it's all right if you have programming and math statistics in your skill set. You can implement machine learning. And if you have subject matter expertise as well as math and statistics, you can do traditional research. It's fun. uh, what I want you to beware of would be the between programming and subject matter expertise. That is the danger zone, meaning okay, since code is easily accessible, you might be tempted to, oh, I apply this algorithm, this process. Well, it's the danger zone because you do not know what you're doing, and it might lead to wasted time, resources. For the final remarks for this presentation, human expertise helps a lot in terms of crafting features from URL construction, domain, content, and we can feed those features to the ML model. So for the blind spots or dimensions beyond human capacity can process, we can turn to natural language processing. And machine learning, while it definitely helps improve protection, we believe that it should not completely take over security mechanisms. So a multi-layered defense and with end-to-end protection is needed to be able to fight both known and unknown security threats. Thank you, everyone.
Thank you for listening. Bye bye.